Welcome to the session on even, odd and prime numbers. We're going to be looking at even, odd and prime numbers on a number line and finding factors. By the end of this lesson, students will be able to show even numbers on a number line, show odd numbers on a number line, show prime numbers on a number line, find factors of a given number, and use factor trees. In our previous lesson, we learnt about even numbers, odd numbers, and prime numbers. Let's review those ideas before extending them. Even numbers can be divided into two equal groups with nothing left over. Consider this example of 6 apples. Can we put an equal number of apples in the two boxes? If we can, without any being left out, then 6 is an even number. So let's try. 3 apples can go in one box, and 3 apples can go in the other box. Since there are no apples left over, or no remainder after sharing them out, then 6 is an even number. Some examples of even numbers are 2, 4, 6, 8, 10, 12, 14, 16, and so on. Notice that all even numbers end in 0, 2, 4, 6, or 8. Now let's consider odd numbers. Odd numbers cannot be divided into two equal groups. One object is left over after dividing into two. Now consider this example of 7 apples. Can we put an equal number of apples in the two boxes? If we can, without any being left out, then 7 is an even number. However, if there is 1 left over, then 7 is an odd number. Let's now try to divide the 7 apples. We can put 3 apples in one box and 3 apples in the other box, and we have 1 apple left over. Therefore, since 1 apple is left over, or there's 1 remainder, we know that 7 is an odd number. Some examples of odd numbers are 1, 3, 5, 7, 9, 11, 13, 15, 17, and so on. Notice that the odd numbers end in 1, 3, 5, 7, and 9. Now let's take a look at factors. What is a factor? Factors are numbers that divide exactly into another number. So consider the number 6. 6 divided by 1 equals 6. 6 divided by 2 equals 3. 6 divided by 3 equals 2. And 6 divided by 6 equals 1. Therefore, the factors of 6 are 1, 2, 3, and 6. Prime numbers are special numbers. They have exactly 2 factors. So, for example, factors of 7 are 1 and 7. 7 can only be divided by 1 and itself. That makes 7 a prime number. Take a look at the numbers on your screen and identify whether they are even or odd and prime or not prime. So, for the number 2, we have that this is even. It of course ends with the digit 2. The number 4 is also even. 5 is odd. 7 also is odd. 8 is even. 9 is odd. 11 is also odd. And 12 is even. Now consider whether these numbers are prime or not prime. So 2 has exactly 2 factors, 1 and 2. Therefore 2 is prime. 4 has more than 2 factors, which are 1, 2, and 4. therefore 4 is not prime. 5 and 7 are both prime. They both each have 2 factors exactly. 8 is not prime. It has factors 1, 2, 4 and 8. So clearly more than 2 factors. And 9, as we discussed earlier, is not prime. 11 is prime. It has exactly 2 factors, 1 and itself. And 12 is not prime. We're now going to take a look at even, odd and prime numbers on a number line. A number line helps us to see how numbers are arranged. Even numbers on a number line. Notice that every second number is even, and that odd numbers fit between the even numbers. All prime numbers except the number 2 are odd. Note that the number 2 is both even and prime. Here are the prime numbers. And here are the odd numbers. And here are the even numbers. We're now going to use the Sieve of Eratosthenes to find prime numbers. This sieve helps us to find the prime numbers up to a given value. In this example, we're going to find all the prime numbers up to 20. So let's begin by first crossing out all the multiples of 2 which are greater than 2. So we cross out 4, 6, 8, 10, 12, 14, 16, 18 and 20, as shown here. Now we cross out all the multiples of 3 which are greater than 3. So in this example we would cross out 6, which has already been crossed out, 9, which now needs to be crossed out, 12, which has been crossed out, 15, which needs to be crossed out, and 18, which has already been crossed out. We'd keep going for all primes up to 20, and this would reveal that the numbers left are the prime numbers. We now consider factors. A factor divides another number exactly with no remainder. So if we consider the number 12, 12 divided by 1 equals 12, there's no remainder. 12 divided by 2 equals 6, no remainder. 12 divided by 3 equals 4, and therefore the factors of 12 are 1, 2, 3, and 4, 6, and 12. What are factor pairs? Factor pairs multiply together to make the number. So for example, the number 12 can be written as 1 times 12, or 2 times 6, or 3 times 4. Similarly, the number 18 can be written as 1 times 18, or 2 times 9, or 3 times 6. And the factors of 18 are 1, 2, 3, and 6, 9, and 18. We will now take a look at factor trees. A factor tree helps us break a number into smaller factors. So for example, if we look at the number 24, we can begin by noticing that 24 equals 4 times 6. And then we can continue splitting until all the branches end with prime numbers. So 4 is equal to 2 times 2. Both of these numbers are prime. And 6 is equal to 2 times 3. And both of these numbers are also prime. So therefore, 24 expressed as a product of prime factors is 2 times 2 times 2 times 3, as shown here. In this session, we've learnt that even and odd numbers can be shown on a number line. We've also learnt that prime numbers can be identified using a sieve, and that factors divide exactly into a number. And finally, we learnt that factor trees help us find prime factors. Now pause the video and have a go at these exercises. Press play when you're ready to view the solutions. Solutions are coming up shortly. This brings us to the end of this session. Do attempt the exercises in your textbook related to this topic. Thank you very much for listening.